Hello, my name is Laurel.
And I'm Gus.
I'm Jade.
And we work for an organization called the Potomac Valley Audubon Society.
In our job, we teach people about nature, and it's our goal to help them appreciate it and want to preserve it.
We are here today to teach you about one huge aspect of nature, water.
In this program, we will talk about where water comes from, where it goes, what is a watershed, and how we can keep water clean and protected for everyone.
71% of the Earth is covered in water. 97% is salt water in our oceans. 3% is fresh water, but only 1% of that fresh water is drinkable because the rest of it is tied up in glaciers and underground aquifers that we can't reach.
All living things need water to survive.
Humans can only live 3 days without water.
Besides drinking, we use water for many things.
There's the same amount of water on Earth now as there was when the Earth was first formed. That means the water from your faucet could be the same molecules that the dinosaurs drank.
All right, in your watershed journal, please record some of the ways that we use water.
What's also really cool is that water can change forms. Look behind us. The rain is water.
Where else can we find water? Well, this ice cube's water. This steam is water.
This is water. Follow along in your watershed journal. The 3 states of water are liquid, solid, and gas. Pause the video here and take a moment to record a few examples of each of these states.
A single drop of water is made up of millions of water molecules. A water molecule is the smallest unit of water. You may have heard of water be referred to as H2O, and that is because it talks about the atoms that make up a water molecule. Water is made up of 1 oxygen atom and 2 hydrogen atoms.
When water changes between different states, its density changes as well. Density is a way that we measure how compact or spread out something is.
Typically, dense objects sink when put in water, and less dense objects float. I have 2 objects here, a rock and a feather. Let's see which one is more dense and which is less dense. When I put the rock in water, it sinks. Let's see what happens when I put the feather in water. It floats. That means the rock is more dense and the feather is less dense. When an object is more dense, its molecules are closer together. How could we show closer together molecules with our bodies? We're really dense. If an object's molecules are less dense, then they are further apart. How could we show that with our bodies? All right, more dense, less dense. Practice with us, more dense, less dense, less dense. Oh, I tricked some of you.
When water changes from a liquid to a solid, the molecules get rearranged and the density changes. We're going to conduct an experiment to see if water is more dense when it is a liquid or a solid. To test this experiment, we're going to see what happens when we put ice in water.
Scientists use the process of the scientific method to study and learn about the world around us. It all starts with asking a question.
Is ice more dense like a rock and will sink, or less dense like a feather and will float?
We need to do the next step in the scientific method. Make a hypothesis.
Stop the video now and form a hypothesis. Do you think the ice will float or sink when put in the water?
Share your hypothesis with another classmate.
For this experiment, you will need a full dish of water and some ice. Drop the ice into the water and watch what happens.
So why does it matter that ice floats? Well, to show you, let's imagine that we have a pond. Our pond is full of all kinds of aquatic creatures, like fish and snails, maybe a turtle getting ready to hibernate, a water snake, minnows, and more. They're all getting ready for the winter months. Temperatures are starting to drop, and once it gets so cold that it's at below 0 degrees Celsius, or 32 degrees Fahrenheit, the water's going to start freezing. So what if the ice sank? Well, then it would freeze from the bottom up, and the pond creatures would freeze too. Luckily, ice floats and forms a sheet at the surface of the water, so the animals can spend their winter living happily underneath. Water's also special because of something called surface tension. Because water molecules stick to each other, these bonds create a skin over the water's surface.
Think about when you do a belly flop. It hurts because you're breaking the surface tension of the water with your body.
Some animals use surface tension to their advantage, like these water striders that distribute their weight with long legs in order to walk across the water.
In this experiment, we're going to see water surface tension in action. For this experiment, you'll need a container of water, a bowl will work fine, and a paper clip. So, to see the surface tension on the water, we are actually going to float this paper clip on the water, just like a water strider would. I've got some tips for this experiment. Only one person's finger in the bowl or container at one time. Make sure the water is very still before you start, and then slowly lower the paper clip into the water. It might take more than one attempt. Do you see the skin on the surface of the water? Thanks for watching.
We're looking forward to talking more about the wonders of water with you in our Zoom lesson.
Don't forget to check out the supplemental video to learn the water cycle song.